Hello students, I am Ravi Shankar Pal from ABES Engineering College Ghaziabad. Today I am going to discuss a topic of data structure that is called asymptotic notations. In this topic basically we will represent the symbolic form of any function. Basically this is related to mathematics, but here we relate this to representing the complexity of any algorithms in symbolic forms. So let's start. First, we know how many types of symbols are there to represent the functions. First one is that is called big omega. That is called big omega notation and represented as big O. This is also known as upper bound. I will discuss about what is upper bound. And second symbol is that is called big, sorry, first one is big O. This is big O. And second one is big omega, represented like this. This is called lower bound of a function. And third one is this is called theta, theta, and represented like this. And this is called average bound. Okay, so let's start about these bounds, yeah, asymptotic notations. How can we use these notations? First, start with the big omega, big O, sorry, big O, big O, big O notation. That is O. For this, suppose we have a function of big O of g of n if and only if fn is less than or equal to c into gn for some constant c and for all n is greater than or equal to n0. To explain this notation, I will take help of this graph. This graph is between time, and input size of the function, and it is represented as n. Suppose there is a function fn is growing like this and another function is growing c and g. Here see here fn is less than or equal to c into gn. Then we can see that if this equality is satisfied for some constant value c and for a value starting from n0 to upper, any starting from n0, that is the initial value from where this equation satisfied, and for some constant c. For examples, if there is a function fn is equals to 3n plus 2, then we can find the relation fn is less than or equal to gn, that is less than or equal to 3n plus 2n is less than or equals to 5n, where if we put n is equals to 1, this relation will satisfy. Fn is, you can write 3n plus 2n. If you put n is equals to 1, then there will be 3 plus 2 is less than or equals to 5. So this relation will satisfied if you put n is equals to 2 in this equation, then this will also satisfied. So here n0 is equals to 1 and this is the value of C. So you can write this Fn is equals to big O of n, where n is equals to G of n. What is the meaning of Fn is equals to big O of n? The meaning of this one is this function is bound to big O of n and it is also bound to, because this is called upper bound. So this is also bound to big O of n square and this is also bound to Fn is equal to big O of n cube. Means if there is a comparison between different function like one constant is less than or equal to root n less than or equal to suppose n less than n square, like this n की power n. Basically this is your exact bound where you relate right now fn. This is the value of function. This value is greater than upper bound for all these values. Upper bound for all these values. This is called upper bound for fn. And this is called lower bound for fn. Lower bound for fn. And this is called average bound. Average bound. But which one is exact bound? Which one is closest? That is big O of n. Next one is big omega. Big omega. This is called lower bound. Lower bound means if function fn is equal to omega of n cube n, then it is also true for omega of root n. This is also true for omega of log n. Means the value, function value, which one is less than n, that is root n, log n and 1. This is also true for all, but which one is exact bound, that is 1. So this is represented as omega of n. And this is also explained in similar way. If there is a relation between input size n and time, and if there is a function fn and this is a function c into gn, and here it is n0, then we can relate this big omega. It is f of n is equals to omega of c of gn if and only if fn is greater than or equal to c into gn for some constant value c, and for all n is greater than n0. For example, if fn is equal to 3n plus 2 and gn is equals to n, then we check for n is equals to 1, it is 3 plus 2, that is 5, and gn is equals to 1. Gn is equals to 1. If n is equals to 2, the 3n plus 2 is equals to 3 into 2, that is 6 plus 2. 6 plus 2, that is 8. and Gn is equals to 2. Similarly, if n is equals to 3, this will be 9 plus 2, that is 11, and Gn is equals to 3. Means for all value n is equals to greater than or equal to 1, it is true that Fn is greater than or equals to Gn. If we multiply this function with a constant value C into Gn, then if we consider C is equals to 1, then it will be 1 into 1, that is 1, 1 into 2 into 1, that is 2, 3 into 1, that is 3. Means this is also true for C is equals to 1. So we can say that N0 is equal to 1 and C is equals to 1. Next one is theta, theta notation. Theta notation. This is called average bound. Average bound. What does it mean average bound? If there is a function f1 is equals to big theta of c of gn, if and only if fn is less than or equal to c1 into gn is less than or equal to c2 into gn for some constant value c1 and c2 and for n is greater than or equal to n0. Graphically we can represent this. This is input size n and this is time, and if this is a function asymptotically growing like this, then this will be the C1 into Gn, that is Fn is less than or equal to 0, and this one will be the C2 into Gn. Fn is lies between Cn and G2. For example, if Fn is equals to 3n plus 2 and Gn is equals to n, then we can calculate this is Fn 3n plus 2 is less than or equal to C1 into Gn is equal to n, and here this is C2 into Gn, that is n. If we put the value of n is equal to 1, then it will be 3 plus 2 is less than or equal to, if we put C1 is equals to 5, it will be 5 into 1, and if we put C2 is equals to 1, it will be represented as 1 into n. Condition will be true. If we will put n is equals to 2, because we will find only a value of C1 on C2. For this, it is also true. We will only change the value of n. If we will put n is equal to 2, then this equation becomes C2 is equal to 1. The 1 into 2 less than or equal to 3 into 2 plus 2 less than or equal to C1 is 5 into n. Here it is 2 and here it is 6 plus 2, that is 8, less than or equal to n is, here n is equal to 2, that is 10. This condition is also true. And similarly it is always greater than true for n is greater than or equal to n, and c1 is equal to 5, c2 is equal to 5. So we can say that fn is equals to big theta of g of n. Here gn is equal to n theta of n. What is the meaning of fn is equals to theta of n? Means this is exact bound. If function relation is this, n is less than n square less than n cube up to n cube, and it is root n log n and it is constant, then this is called theta bound. Actual, we represent in this form only. This is called average bound. There is no upper and lower bound for this. And these are called, if we do not find the exact place for this function, then we can represent in either in upper bound or in lower bound. Okay. If you found the exact value, then it is represented as theta n. So this is all about the asymptotic notation. These are the references where I have taken the content. Thank you for listening.